In number 15 in section 10.3, they ask you to graph this and then use the horizontal line test to determine if it has an inverse function. And then if it does have an inverse function, they want you to find it. It didn't tell you to graph. Oh, it did. Wait, let's see. It doesn't say graph it, but it says verify your graphs on a computer or graphing calculator, which implies that you were supposed to graph both of them, even though they didn't say that. Okay, I don't know anything about this function. I don't know how to graph it, so what am I going to do? I'm going to make a table of values, and this is going to be kind of probably really hard to get a good graph of, just because it's the bigger that x gets, the closer this is going to get to 0. So let's think about what values to choose. Actually, if you think about it, this is a rational function. You could rewrite this as 8 cubed, which is, what, 243, I think. Let me check on my calculator. 8 cubed. That's 512. 512 over x cubed. Okay? So if I'm going to graph this, if you think about this being a rational function, what that means is I know that if I set the denominator equal to 0, first of all, there's nothing that's going to cancel, no factors that cancel out of the top or the bottom. But if I set the denominator equal to 0, it's going to be undefined. So that's going to be where I have an asymptoted. It's x equals 0. So I could draw that in, and that's what I'm doing right now with the black. And the closer that x gets to 0, the bigger the number is going to get. For instance, if I were to plug in 0.0001, and you could do this in your calculator if you wanted to kind of look at this, and you were to divide 512 by .001, let's put 2 zeros, it ends up being 512,000, okay? So what does that tell me? That tells me that the closer my graph is getting to the y-axis, the closer that x gets to 0, it's gone to infinity. As a matter of fact, it probably wouldn't hurt here to put your graph on a graphing calculator and kind of look and see what it's doing, okay? So it's going up really high here, and if you, from the other direction, if you get close to x, it's like negative 0.001, it would be negative 512,000. So it's gonna go down like this on the other side. Now, if you think about x-intercepts, take your numerator and set it equal to 0. Are you going to have any x-intercepts? No. 512 does not equal to 0. There's no x or anything to set equal to 0. So that kind of tells me that it's the x-axis is probably going to be an asymptote too, and you can verify that by looking at your graphing calculator. Now, if you want to go and get some good points, it's going to be hard to graph anything. The easiest thing to graph is going to be, what if you plugged in x is 4, 8 divided by 4 is 2, and 2 cubed is 8. And if you plugged in negative 4, 8 divided by 4 is negative 2, and negative 2 cubed is negative 8. And honestly, can I tell you how I got that? I looked on my calculator and saw that and thought, oh yeah, that's going to be the easiest one to graph. So don't be afraid to use your graphing calculators here. At negative 4, you're at negative 8. Okay, so it's like right here. So that means what I should have done here is probably had this kind of swing through here and get on down like this. This is not real accurate here. And then over here at 4, it's going to be up at 8. So let's say that's about right there. That means this is probably going to be coming down like this and heading really fast. It's still got the shape of you can see it on your calculator like this and like this. It's just that it's coming down really fast and dropping to kind of do that, okay? Let me kind of clean that up and do a red graph that might... That one's not too bad. This one up here, you're probably not going to be able to see the shape of it just because it's, you know, we need a bigger graph to really see this very well. Okay, but the general shape is like what I've drawn down here, and I'll circle. Now, if you do the horizontal line test, this is going to pass it because these are not horizontal lines here. They're getting closer and closer to 0, but they're really not hitting the same value. They're not hitting the exact same value every time. They're getting really close to 0, but not hitting it. So this one does have an inverse. So if I write the function as y equal, I'm just going to do 8 over x cubed. I'll write it like that with a y instead of the f of the x. If I want to find the inverse, then I switch the x and the y, so that would be 8 over y cubed. Okay, and then let's see, then I'll need to solve for y. So let me see, this is x equal 8 cubed over y cubed. And I'm going to just turn this into a proportion. I'm going to put this over 1 and cross multiply. I get y cubed times x is equal to 8 cubed. Okay, and then to get, I could divide both sides by x, and that would get rid of that. And then I've got y cubed on this side, so I could cube root both sides. And so what I would get, let me write my answer way over here to the left because I'm out of room. The cube root of 8 cubed is just going to be 8. So this would be the cube root. It would actually be, you could write it as 8 divided by the cube root of x is equal to y. That's the inverse right there. Now if I wanted to graph it, and again this is going to be awfully hard to graph, especially with the mess that I've got drawn on here. If I were you, I would just look at it on my calculator, type that in and look at it on the calculator, because if I reverse those points, I'm going to have 8, 4, which means I'll have a point about here. I'll have negative 8, negative 4. All I'm doing is flipping the points in that table over there. And let's see, it's kind of hard to get anything else because our graph was not, this scale was not so great, was it, for the graph that we want. But if you were to draw it, let's draw in the line y equal x. That's what they're supposed to be reflected about. So if this is here, you know what, I would just look at my graphing calculator to get this one. We don't really have enough good points to graph it, and our scale is so horrible. Look at your graphing calculator on this. Go ahead and go put this one on line 1. And then on line 2, type in what we got right here, y equal 8 divided by, and then put the cube root of x. So let's see, you can write that as x, you change it over to a radical, raised to the, in parentheses, 1/3 power. So I'm going to write what I typed in down here in purple. This is what I typed in my calculator, 8, oh, that's not purple, 8 divided by, so I put a fraction bar, x raised to the, and in parentheses, 1 divided by 3 power. And if you look at that on your calculator, it's interesting. It almost looks like the same sort of thing. If you notice, you're coming in like this. It's slightly different. Okay, it has to go through this point, -4, -8, so it might be like something like this. And over here it comes in a little tighter, something like this. They really look a lot alike. Look at them on your graphing calculator instead of this, because this is a big mess. Look at the graphing calculator. And anyway, graphing that's kind of hard just because of the nature of it, so I think the graphing calculator is the better way to go there. Alright, if you look at this one's going to be kind of a difficult one. Well, let's look at this first. If it doesn't have an inverse, we don't have to find it. Okay, let's plug in some points like -2, -1, 0, 1, and 2. Again, you could go to your graphing calculator for this. -2 to the 4th power is 16, -1 to the 4th power is 1, 0 to the 4th power is 0, 1 to the 4th power is 1, and 2 to the 4th power is 16. Could have gotten that off your graphing calculator. Alright, if you go to graph this, because that's what they really want you to do, I know that my y-axis here is counting by 1, but let's count by 2. So this would be like 2, 4. I'm going to have to do that in order to get this on there. So if I graph -2, 16, -2, 16 would be like here, because this would be like where 16 is, okay? And 2, 16 would be up here. 0, 0 would be here. 1, 1 would be here, and -1, -1 would be here. This thing kind of comes in And it does this teeny tiny bounce down here that we're not picking up, but you might see if you did it on your graphing calculator and you might have to plug in some points like negative 0.1 and 0.1. You'd kind of start seeing there's a teeny tiny little bounce there that you really can't pick up when we graph it, okay? But that purple graph is representative of y equal x to the fourth. And again, maybe put it on your graphing calculator and change your window. You'd want to have at least going up to 20. You'd want to have your x min maybe be, if you wanted to stretch it out, you could just leave it at negative 10 and x max 10 on your graphing calculator. But if you wanted your y min to be maybe negative 20 and your y max to be 20, and maybe you count by twos, so y scale would be 2, you would get a good picture of this. The good thing about this is if you do the horizontal line test, there is no inverse. It fails the horizontal line test because it hits twice, one here, one here. It is a function. The original is a function because it would pass the vertical line test. But the inverse, if we do the horizontal line test on this, is not a function, so the inverse, we would just say that inverse doesn't exist. Now that doesn't mean that we couldn't play around with it. What we do with it in calculus is just say, well, since I can't look at the whole thing, what I'll do is look at a part that would be a function. So what you usually do is you split it in half and look at this half of it. That's kind of how we deal with it when we get into the calculus if we need to do something with it.